Hello and welcome. My name is Serene Bahi, and for my Kilachand Honors College Keystone, I chose to focus on antibiotic resistance, one of the biggest threats to the health of the world's population. Given that animal agriculture is one of the largest consumers of antibiotics, I reviewed literature on how agricultural antibiotic use affects the spread of antibiotic resistance. A major literature review from 2016 entitled The Review on Antimicrobial Resistance estimated that 700,000 deaths annually can be attributed to resistant infections because we are running out of effective antibiotics. The World Health Organization's list of critically important antibiotics for the maintenance of human health all have reported resistances in commonly pathogenic or infection-causing bacteria. The same review predicted that if antibiotic use goes completely unchanged, deaths annually will rise to 10 million by 2050. This is particularly relevant in animal agriculture because of the amount of antibiotics used. It's estimated that over 70% of the antibiotics produced in the US are used in livestock as a growth promoter. Even more is used for actually treating disease in that same livestock population, where only 9% is used to treat human disease. Antibiotic use can contribute to an increase in the prevalence of resistant bacteria because resistance exists naturally as genetic variation in a bacterial population. Antibiotic use then kills the bacteria that are sensitive or not resistant, leaving only the resistant bacteria to thrive. The majority of resistance mechanisms are acquired through the transfer of genetic material, typically in the form of plasmids, which are circular DNA that only bacteria can express. Here, a resistant bacteria can transfer a copy of the gene conferring resistance to a normally sensitive bacteria, thereby also making it resistant. That means that even if resistance develops in bacteria that aren't adapted to affect humans, resistance can still spread to pathogenic bacteria. Resistant bacteria in animals can affect human health through direct contact with animals or their products, or indirectly through environmental contamination. In 1977, the FDA performed a study that found that feeding animals low doses of penicillin and tetracycline promoted antibiotic resistance in bacteria that were capable of infecting humans. In 1978, Stuart Levy was able to demonstrate through examining fecal samples that antibiotics in chicken feed resulted in increased resistance of the intestinal bacteria of the chickens and in the farmers who raised them. This was then found to be able to spread to individuals that the farmers came in contact with, even if those individuals had not directly interacted with the chickens or the antibiotic feed. A study examining methicillin-resistant Staph aureus bacteria, also called MRSA, in 2013, examined strains from infections in farmers and was able to confirm through genetic analysis that it was the same resistant bacteria that was isolated from their farm animals. This is especially concerning given how contagious MRSA is and how difficult it is to treat. Colistin, which is a last line, meaning a last resort antibiotic for very severe infections and is defined by the World Health Organization as a highest priority, critically important antibiotic, has already demonstrated resistance in the form of a plasmid called MCR1, which has been identified in bacteria from animals and humans. A study from China in 2016 found that the prevalence of MCR1 was high in bacterial samples from pigs and in retail pork. And though it was still relatively low in human infections, the fact that we can find it in bacteria that cause human infections indicates that it's already spread to pathogenic bacteria. This decrease in prevalence from animal to meat to human that we observe indicates that animals are the source of the plasmid. This finding led to a ban of agricultural colistin use in China and India, but we continue to find MCR1 in human infections, which indicates that this ban was too late. Resistance can also spread indirectly through manure of antibiotic-fed animals, which allows resistance to be transferred to bacteria that are naturally present in the soil. Water drainage from that soil then contains bacteria with the same resistances as does bacteria from the manure. The manure on its own even can create contaminated water that plants take up. Every case of fruit and vegetable related food poisoning that's been investigated by the CDC has been traced to contaminated runoff from animal farms. One study has found that resistance can even spread to bacteria present in the air. In this study, they isolated bacteria from the air around conventional cattle farms that use antibiotic supplemented feed and organic farms that reported no use of antibiotics, and isolated them and tested for resistance. They found that the prevalence of resistance to common antibiotics like penicillin was at least twice as high in the bacteria around the conventional farm as it was the organic farm. It's clear that we need legislation that bans the non-therapeutic use of antibiotics in factory farming. The World Health Organization, the American Public Health Association, and the American Veterinary Medical Association have all been calling on us to do this for years. When the FDA performed this study that we previously discussed in 1977, they proposed legislation that would revoke the use of penicillin and tetracycline in farming, but withdrew it eventually in 2011 after no action was taken by Congress following public opposition from the farming industry. It's likely that the economic interests of this factory farming industry are preventing a ban like this. This inaction leaves it up to the consumers, but choosing products labeled as antibiotic-free isn't enough given that there's no actual definition or regulation for this term. As a result, consumers in areas of the world like the US, India, China that depend on antibiotic use to be able to consistently meet animal product demands need to shift away from dependence on these products. Increased demand for animal products that aren't produced with antibiotics and decreased overall demand for these products will force the industry to make this change to survive. This needs to happen as soon as possible because once resistance is present in a bacteria that is adapted to live in and spread among humans, changes in agricultural antibiotic use won't be able to stop it. Thank you for listening. Let me know if you want access to any of the resources I discussed here, and I'm happy to take your questions. Thank you.